Welcome, curious minds, to the deep dive. Today we're plunging into one of the most intriguing and persistent mysteries in mathematics and physics, the infamous Navier-Stokes equations.
That's right.
You might not know their name offhand, but you encounter their effects every single day.
That's free.
Seriously. Think about the intricate way cream swirls into your coffee, forming those fleeting patterns, or the colossal complex dynamics that drive our global weather systems, dictating everything from, a gentle breeze to a hurricane.
Absolutely essential stuff.
Or even consider the precise fluid mechanics essential for rocket propulsion, lifting humanity into space. These equations are the bedrock, the absolute foundation for describing fluid motion. Yet despite their omnipresence, their fundamental behavior, especially when things get turbulent, remains shrouded in really profound mystery.
It really does.
And at the heart of this mystery lies a truly profound question, one so challenging it's been designated a claimed Millennium Prize Problem.
One of the big ones.
Exactly. Do smooth initial fluid flows. Imagine a perfectly calm, predictable stream, or water gently flowing from a tap. Do they always remain smooth and predictable? Or can they spontaneously develop blowups, these points where velocity or pressure theoretically become infinite?
Right, where the math just breaks.
Precisely. Moments where the equations, as we currently understand them, would essentially break in finite time. And this isn't just some abstract mathematical puzzle for academics to ponder.
No, far from it.
If such singularities truly exist, it has profound implications for our understanding of the very fabric of reality. And it could completely reshape countless engineering applications, from designing more efficient aircraft to predicting climate change with, hopefully, greater accuracy.
It's an excellent point to emphasize the practical side alongside the theoretical. For decades, the greatest minds in mathematics and physics have wrestled with this. The immense difficulty. It doesn't stem from a lack of powerful computers or brilliant people, but from the inherent complexities when fluids move in 3 dimensions, especially when you consider turbulence. We can observe it, simulate it, even approximate turbulent flows pretty accurately in many cases. But understanding them from first principles, actually mathematically proving they never break down into infinite values, proving global regularity that has remained elusive.
It's like this Mount Everest of math and physics.
It really is. Sits right at that intersection of pure math and observable physical reality. And it's resisted every attempt so far.
And it seems like trying to climb that Everest with just the existing tools, well, it just hasn't been enough. But what if there's a fundamentally new way to approach it? That's precisely what a groundbreaking new framework called the Unified Coherence Theory of Everything, or UCTE, aims to do.
Okay, UCTE.
And this isn't just another incremental attempt to sort of patch up the old equations. It's a bold, ambitious framework offering what they call a coherence-regulated augmentation of Navier-Stokes.
A coherence-regulated augmentation. Interesting phrasing.
Isn't it? And its scope is audacious. It actually bridges mathematics, physics, cosmology, even artificial intelligence.
Wow, okay, that's broad.
It really is. So today we're going on a deep dive into the heart of this theory. We'll explore how UCTE uses something called Noetherian-Finsler numbers.
Noetherian-Finsler numbers, okay.
A concept of coherence vacuum activation, and an ontological eigenmode framework to completely reshape our understanding of the universe. So get ready to maybe rethink some fundamental assumptions as we explore how UCTE claims to finally resolve this centuries-old puzzle. Okay, so to really get what UCTE is trying to do, we need to first just appreciate the sheer scale of the challenge, right? The actual wording of the clay Millennium Prize question for Navier-Stokes. It's phrased very carefully.
Extremely carefully. Every word matters.
He says, for smooth, divergence-free initial data, do the incompressible Navier-Stokes equations admit a global smooth solution? Or can finite time blowups occur? Okay, that sentence, while technical, it carries immense weight. We need to break that down.
Absolutely. Let's unpack that. Smooth, divergence-free initial data. Smooth here is a specific mathematical term. It means the fluid flow is continuous, differentiable everywhere.
So no sharp corners or sudden jumps.
Exactly. Imagine not just a still pond, but a fluid where you can draw a curve through it, and you always know its exact velocity and pressure at every single point. And those values change smoothly. No abrupt changes, no kinks. It's perfectly well-behaved mathematically.
Okay. And divergence-free.
Divergence-free means the fluid is incompressible. This is really key. Locally, at any point, there's no net inflow or outflow of fluid volume.
So fluid isn't just appearing or disappearing out of nowhere.
Precisely. It's a very good approximation for liquids like water under normal conditions, and it simplifies the equations a lot while still capturing the essential physics. So we're starting with these perfect, orderly, predictable conditions.
Right. Perfectly behaved fluid to begin with.
Exactly. Now, the core question. Do the incompressible Navier-Stokes equations admit a global smooth solution? This asks if, given those pristine starting conditions, the fluid flow will always remain well-behaved and predictable for all time.
Forever, no matter how long you let it run.
For all time, throughout its entire evolution, velocities, pressures, they never become infinite. They never develop sharp, unphysical edges. The math never breaks.
Okay, that's the smooth solution part. What about the alternative?
The alternative, or can finite time blowups occur? That's where the theoretical trouble lies. A finite time blowup means that at some specific moment, in a specific place, the fluid's velocity or pressure would suddenly shoot up to infinity.
Infinity, like actually infinite.
Theoretically, yes. Think of an ocean wave getting steeper and steeper, but instead of breaking, it just keeps getting infinitely tall and infinitely sharp. Or a tiny spot in the fluid developing infinite energy density. Infinite stress. If that happens, our current equations literally fail. They can't describe what happens next. It's like a catastrophic internal collapse of the mathematical description.
So it really does sound like we're asking if the universe in its fluid motions ever just glitches out permanently.
Yeah.
In a way that our math just can't handle.
That's a good way to put it.
Why has this question, it seems simple on the surface, why has it stumped the best minds for so long? What are the structural weaknesses in the classical understanding that UCTE says it can fix?
That's really the crux of it. The standard Navier-Stokes equations, they're incredibly powerful, don't get me wrong, but they hit these specific structural weaknesses when you push them into highly dynamic three-dimensional flows. It's not so much a flaw in the equations as a description of bulk fluid motion, but maybe an incompleteness when dealing with the extreme conditions turbulence can whip up. 1.2 key obstacles identified by UCTE in classical fluid dynamics. So UCTE points to a few critical obstacles in classical fluid dynamics that have blocked a resolution. The first, and probably the main culprit, according to UCTE, is nonlinear vorticity stretching.
Okay, vorticity stretching. Let's break that down. What's vorticity?
Vorticity is basically the local spinning motion of a fluid. Imagine putting a tiny, frictionless pinwheel in the flow. How fast it spins tells you the vorticity. You see high vorticity in things like whirlpools, tornadoes.
Right, the spin. And the stretching part.
Stretching is what happens when these spinning bits of fluid, often organized into what we call vortex tubes, think mini tornadoes or smoke rings, get elongated, stretched out.
Like pulling taffy.
Kind of, yeah. Think of a figure skater pulling in their arms. They spin faster.
Right, conservation of angular momentum.
Exactly. In a fluid, if you stretch a vortex tube in 3D, its diameter shrinks, and its rotation speed skyrockets. It concentrates energy into smaller and smaller scales. And this is inherently nonlinear.
Nonlinear,
meaning the fluid's own motion affects how it gets stretched, which then changes its motion, which affects the stretching. It's a feedback loop, a powerful, self-reinforcing one. This intensification cascades energy down to tiny scales, and that's where the potential for instability for those blowups comes from.
And this only happens in 3D.
Yes. In 3D, you have that extra dimension allowing stretching along the axis of the vortex tube. That specific mechanism lets the energy concentrate so fiercely. In 2D, you can rotate vorticity, spread it out, but you can't stretch it along its axis like that.
So the fluid itself is kind of creating the conditions for its own potential breakdown by concentrating energy in these shrinking, spinning vortices. And UCTE says the classical equations just let this happen. There's no built-in stopgap.
Precisely. And that leads straight to the second obstacle UCTE highlights, the absence of an inherent coherence-preserving regulator in classical fluid dynamics.
Coherence-preserving regulator.
Yeah.
Okay.
In simpler terms, the classical equations, as they stand, lack a built-in fundamental mechanism to maintain stability or coherence when faced with these intense nonlinearities. There's nothing intrinsic that says, hold on, this vortex is stretching too fast, energy's getting too concentrated, let's apply some natural damping to stop it from going infinite.
It's missing a fundamental stabilizing principle.
Exactly. It's like designing a race car purely for speed, but forgetting to put in a governor or advanced brakes to handle extreme acceleration, especially the kind that feeds on itself.
That feels like a pretty big omission, if true. It suggests our current understanding might be fundamentally incomplete. Maybe there's some internal self-organizing principle we haven't captured.
That's precisely the argument. And adding to that, UCTE argues that viscosity, as modeled classically, is an insufficient constant scalar.
Viscosity. It's like the fluid's thickness, its resistance to flow. Honey versus water.
Exactly. In classical Navier-Stokes, for many situations, viscosity is just treated as a fixed number, a constant value for a given fluid and temperature. But UCTE suggests the static constant model is insufficient to stabilize the entropy cascade.
Okay. Entropy cascade, related to the energy cascade.
Very related. Entropy measures the rotational energy, the intensity of the vorticity. The entropy cascade is how turbulent eddies transfer this rotational energy to smaller and smaller scales, where it eventually dissipates as heat due to viscosity. But if viscosity is just a fixed passive number, it's like a static defense against this incredibly dynamic, self-amplifying threat of vorticity stretching. UCTE argues it simply might not be strong enough or maybe not smart enough to prevent this cascade from potentially running away to infinity in 3D, where energy can concentrate so fast.
So it's like using a standard brake pad on a car that's somehow generating its own accelerating force down a steep, twisty hill. It just gets overwhelmed.
That's a great analogy. It can adapt. And finally, there's that critical difference between 3D versus 2D flows. We know, mathematically proven, that global smoothness holds for 2D Navier-Stokes.
Because you can't stretch the vortices in 2D.
Right. No axial stretching means no runaway energy intensification. But add that third dimension and the nonlinear convection term, how the fluid moves itself around, becomes destabilizing. That extra dimension isn't just more room, it fundamentally changes how fluid elements interact, specifically allowing that crucial stretching, amplifying instability, and making the proof for global regularity just intractable with classical methods.
Okay, so the classical picture has these inherent vulnerabilities, especially in 3D, which is, the world we live in. Missing regulator, maybe viscosity isn't smart enough, and this vortex stretching issue. It really sounds like we've been trying to solve this puzzle with key pieces, missing pieces, related to how the fluid maintains its own internal order, how it stops itself from descending into chaos. How does UCTE propose to fix this? How does it add that missing regulation, that coherence?
This is where UCTE really makes its move. Instead of just banging their heads against the classical equations, hoping to prove smoothness for a system that might inherently lack the necessary stabilizing features, they introduce an augmented system.
Augmented, not replaced.
Exactly. They enhance it. They embed new fundamental coherence dynamics directly into the equations. 2.1, the augmented Navier-Stokes system. So the modified equation UCTE puts forward looks like this. Partial oscil plus NF2 plus U NFO, and crucially, still with $1, the incompressibility.
Okay, that looks familiar, but with extra bits. Let's break that down.
Right. The first few terms are the classical workhorses. Partial to U is just how velocity changes locally over time. Is that convective term, how the flow carries itself along, the pressure gradient driving the flow, and natural dollars is still incompressibility. No surprises there.
Okay, standard stuff, but then the right-hand side gets interesting. Two new terms. What are these N and punt doing? What's the radical shift here compared to classical thinking? How do they even fit in?
That's the perfect question. The radical shift is moving from seeing fluid properties as passive and static to seeing the system as active, dynamic, and self-regulating, governed by internal coherence principles. It's a fundamentally different view.
Active self-regulation.
Okay, so first, new term. Psi NFE, this is the effective viscosity term. Notice, viscosity Rin is no longer just E, a constant. It's a function of something called the Noetherian-Finsler four-tuple NFE.
So viscosity changes based on this NFE.
Precisely. It means the fluid's resistance to flow dynamically adjusts itself. It gets stronger or weaker based on the fluid's internal coherence state. It's not fixed, it's an adaptive response.
Wow, okay, that's already a big change. And the second new term?
The second one is TE, NFE. This is the coherence stress tensor. Think of it as an additional intelligent force or stress that UCTE adds to inject damping into the system.
Damping meaning it slows things down, prevents runaway effects.
Exactly, but crucially, this damping isn't just applied everywhere, all the time. It's precisely regulated by those same coherence parameters in envol, and it acts specifically when and where the fluid is approaching instability. And it also has this neat property of vanishing as a parameter, epsilon goes to 0, which is vital for connecting back to the classical equations. These two additions fundamentally change the game. They turn Navier-Stokes from potentially unstable equations into a self-regulating coherent system. 2.2, the Noetherian-Finsler four-tuple.
This NFL, the Noetherian-Finsler four-tuple.
Right.
That sounds like the absolute core of UCTE's idea, way more than just parameters. You said it embeds coherence directly. Tell us about these four components: kappa, alpha, gamma, delta. What do they represent? How do they work together? And you mentioned coherence vacuum activation earlier. How does that fit in?
You're absolutely right. The rasa is central. It's the heart of the paradigm shift. These four parameters together describe and regulate the intrinsic order and stability within the fluid. And importantly, UCTE argues they aren't just arbitrary numbers you tune. They're derived from deeper, almost ontological principles, like finding fundamental constants in physics.
Okay, so let's meet the cast. Kappa.
Kappa. Kappa is the symmetry coherence coefficient. This is all about maintaining ordered patterns, preventing chaotic breakdown. Think of a perfectly formed, stable vortex ring, or even the spiral arms of a galaxy structures with inherent symmetry. Kappa quantifies how well that symmetry and order are preserved against forces trying to disrupt it. It reflects the fluid's innate tendency towards organization. Higher cap, more self-organization.
Okay, so kappa likes order. What about alpha? It's called the asymmetry resonance driver.
Yeah.
Asymmetry sounds less orderly.
It does, doesn't it?
Yeah.
This is fascinating. UCTE suggests even asymmetry plays a constructive regulating role. ATU drives a kind of resonance that helps channel energy, not into destructive blowups, but into stable, coherent patterns. It's how the system uses imbalances or deviations from perfect symmetry to find new, robust states of order rather than just collapsing.
So it uses asymmetry to find a different kind of stability.
Exactly. Think of how a slightly asymmetric aircraft wing can actually improve stability, or how controlled dissonance in music creates richness. It's about using dynamic tension constructively.
Interesting. Okay, third is gamma, the coherence phase angle. Phase angle makes me think of waves lining up.
That's the right intuition. In physics, phase angles often relate to synchronization. Here, describes the ordering or synchronization of coherent structures within the fluid. Imagine different eddies or vortex tubes not as totally separate chaotic things, but as having a precise phase relationship, a kind of collective timing or alignment. It's about how these dynamic parts move in concert, harmonizing their behavior to maintain overall system order. Less about individual parts, more about their coordinated dance.
A synchronized dance within the chaos.
Yeah.
Okay. And the last one, delta. Tell us. Dynamic viscosity modulation. This sounds directly linked to that adaptive viscosity term.
It is. This is crucial. Dellers means viscosity isn't just a passive constant. It's actively adjusted, modulated based on the fluid's current coherence state, influenced by the other NFNs. If the fluid starts losing coherence, getting near instability, Deller kicks in to tweak the effective viscosity, increasing it maybe, just where and when needed to dampen the instability and restore order. This is a radical departure from viscosity being a fixed property.
So the fluid can effectively thicken itself locally when it senses trouble.
That's a great way to think about it. And this active modulation, this inherent responsiveness, connects to that idea of coherence vacuum activation. UCTE proposes the vacuum isn't empty space, but a dynamic medium with its own coherence properties.
The vacuum itself has coherence.
According to the theory, yes. The NFNs act like fundamental eigenmodes or parameters that mediate interaction with this coherent vacuum. So when adjusts viscosity, it's not just the fluid changing, it's the fluid interacting with and leveraging these fundamental coherence fields of the vacuum itself. It taps into a deeper level of reality to maintain stability.
Wow. Okay. So these NFNs aren't just numbers plugged in. They represent this deep dynamic regulatory system that was missing. They embed coherence directly into the equations by describing how the fluid interacts with itself and even the vacuum to stay stable. It's like giving the fluid an internal governor, maybe even an immune system that taps into the universe's own coherence. That's
a profound leap.
2.3 effective viscosity and coherence stress tensor.
It is a profound leap. And that internal governor, that immune system analogy, is perfect. The dynamic interplay of these NFNs then shows up physically and mathematically in those two new terms in the equation.
Right, the effective viscosity and the coherence stress tensor. Let's look closer at those.
Okay, first, the dynamic effective viscosity. We said it adapts. A critical aspect, mathematically, is that it's bounded below by $8.
Meaning it can never drop to zero.
Exactly. No matter how the NFNs adjust it, there's always a minimum positive resistance to flow. This lower bound is vital for mathematical stability. It guarantees there's always some dissipation, some braking effect, preventing velocities from just running away to infinity. It ensures viscosity, now acting intelligently, provides a reliable, always present mechanism for managing energy. It's an adaptive brake that never completely fails.
Okay, so viscosity is smart and reliable. What about the other term, Kyria NFE, the coherent stress tensor? You called it an intelligent regulator.
That's its role. It injects damping near instability and vanishes as T2-else. The key is near instability. It doesn't just apply brakes everywhere, which would be inefficient. It acts like a targeted intervention.
Like an emergency brake that only engages when needed.
Precisely. It senses when and where the fluid is approaching an unstable state, maybe where vortex stretching is getting out of hand, and applies selective damping right there to restore coherence, like a finely tuned control system monitoring the fluid's health. And crucially, as the fluid gets more coherent, or as we consider that limit where its activation is minimal, the Dale-Dollar limit, this extra damping gracefully fades away. It vanishes smoothly, so it doesn't mess with the flow when things are already stable.
Smart, targeted, and disappears when not needed. Elegant. 2.4 key insights of UCTE's approach. A paradigm shift. These additions, they really represent a fundamental shift in thinking, don't they? From passive description to active self-regulation. What are the big takeaways, the really profound conceptual shifts, the aha moments UCTE offers with this?
I think there are two major ones. First, turbulence itself is reframed. It's no longer primarily seen as this chaotic, unpredictable mess of energy dissipation. Instead, UCTE frames it as a coherence-regulated cascade.
Coherence-regulated cascade, not chaotic.
The classical view often paints turbulence as a wild, uncontrolled tumble of energy from big eddies down to small ones, dissipating randomly. UCTE fundamentally redefines this. It proposes this cascade is actually a highly ordered process, governed at every step by these underlying coherence principles, regulated by the NFNs.
So even within the storm, there's a kind of hidden order.
Exactly. Think of it less like a messy brawl and more like a complex symphony. Even the loudest, most intense parts are coordinated and regulated, preventing total breakdown. The NFNs are constantly working, maintaining a dynamic balance, fostering self-organization, even in what looks like chaos from the outside.
That's a huge shift in perspective. What's the second big insight?
The second one is maybe even more profound. It completely redefines what we mean by blowups or singularities. Apparent singularities correspond to dimensional phase transitions into coherent attractor states, not failures of the equations.
Oh, okay. Unpack that. Dimensional phase transitions, coherent attractor states. What does that mean?
This is a massive aha moment. UCTE suggests those theoretical points of infinite velocity or pressure, the blowups, they aren't actually failures of physics or math. They're not the system breaking down. Instead, they represent moments where the system transforms. It undergoes a dimensional phase transition.
Just shifts dimensions.
Effectively, yes, or shifts into a different kind of state space. It reorganizes itself into a new, stable, coherent attractor state. It's not breakdown, it's profound reorganization into a new form of stability. Maybe that stability exists in a way that's not easily described in our usual 3D space, maybe requiring a higher or lower dimensional perspective mathematically.
Mind-blowing. So instead of the universe glitching or hitting a wall, it just shifts gears. It finds a new, stable way to exist, guided by these coherence attractors. That implies a fundamental self-healing or self-organizing principle, even at the edge of chaos. Could this apply to other singularities in physics, like black holes or the Big Bang? And what would these coherent attractor states look like?
That's exactly the implication, and it speaks to UCTE's ambition. If these aren't blowups but transformations, it points to a pervasive self-organizing principle in reality. The universe actively seeks coherence, even under duress. So yeah, maybe a black hole singularity isn't infinite density, but a transition to a different dimensional phase, a highly coherent state beyond our classical description. Maybe the Big Bang was an infinite point, but a phase transition into our 3+1 spacetime from a prior coherent state.
That's radically different.
It is. As for what these coherent attractor states look like physically, they might not be directly observable in our standard 3D view. They could be stable configurations where energy is incredibly concentrated but perfectly organized. Imagine a vortex that, instead of shredding itself, folds or compacts its energy into a stable, higher dimensional, mathematically speaking, coherent structure. We might not have seen them because our models didn't even allow for their possibility. The system finds a new equilibrium, a new coherence, rather than failing. These two insights, turbulence as regulated, singularities as transformations, they fundamentally change the game. But grand ideas need solid math. How does UCTE actually prove this works?
Exactly. The proof is in the pudding, as they say. Proposing these amazing concepts is one thing, but resolving a Millennium Prize problem needs rigorous math. So how do UCTE's three big mathematical innovations, this admissible stress tensor, the uniform Sarin class bound, and the vanishing activation limit, actually lock together to prove global smoothness?
The constructive proof strategy in UCTE is quite elegant, really. It integrates these three pieces like building a very stable bridge, where each part is essential and supports the others. 3.2 admissible stress tensor in detail. Let's look deeper at that admissible stress tensor. We said it adds damping, but its admissible properties are key. It adds selective damping proportional to coherence density, and it vanishes smoothly as sue into dollars. Selective is crucial. It doesn't just damp everything everywhere.
Right, it's targeted.
Exactly. It acts where and when needed, and its strength is linked to the coherence state, like an internal sensor detecting impending trouble. And the vanishing smoothly as sue into dollars is mathematically elegant. The effect fades gracefully as this tuning parameter gets small, no sudden jumps.
Okay, selective smooth vanishing. What makes it truly admissible?
This is the absolute killer property, physically and mathematically. It never injects energy. Mathematically, alt HE dollars.
Meaning it only ever removes energy, or at least doesn't add any?
Precisely. If this tensor added energy, it would likely make things more unstable, leading to more blowups, not fewer. By guaranteeing it only removes or redistributes energy in a way that preserves coherence, without increasing the system's total energy, UCTE ensures the system stays physically realistic and mathematically well-behaved. It's purely a regulator, a sophisticated way to dissipate or manage excess energy safely, never an amplifier of chaos. It respects fundamental conservation laws while adding control. 3.3 uniform Sarin class bound. Okay, so building on this well-behaved stress tensor, UCTE then achieves something huge, a uniform Sarin class bound. The mathematical statement is to all of force, and the key part is it's uniform and HE.
Okay, Sarin class bound. That sounds important in the Navier-Stokes world. What does it tell us?
Oh, it's huge. James Sarin established specific mathematical conditions, criteria, that if a solution to Navier-Stokes meets them, it guarantees the solution is regular, no singularities. Achieving any Sarin class bound globally in 3D has been a major roadblock for decades.
So UCTE claims they've done it.
They claim they've achieved a uniform Sarin class bound for their augmented system. Global boundedness basically means the fluid's velocity stays finite. It doesn't blow up anywhere, anytime. The specific math notation, 44 $TL6b, describes this control rigorously, looking at how velocity behaves on average over space and time in specific ways related to energy and rotation. The core idea, velocities stay under control.
So no matter how wild the flow looks, speed and pressure don't hit infinity, they stay contained. That seems critical. But you emphasized uniform in time. Why is that the game changer?
Exactly. Boundedness is crucial, and uniform in time is the mathematical linchpin. It means this bound, this control over the velocity, holds true regardless of the value of t as long as it's positive.
It works no matter how strong or weak that extra coherence term is.
Precisely. The regularity of the augmented system doesn't depend on the specific strength of the coherence stress tensor. This robustness is incredibly powerful. It guarantees the good behavior is inherent and allows for the final step. Transitioning back to the classical equations while carrying over this guarantee of global regularity. The solution isn't just an artifact of the added terms, it persists even as those terms fade away. 3.4 vanishing activation limit. And that brings us to the third piece, the vanishing activation limit. This ties it all together beautifully. We already know that as the order of dollar, the stress tensor also goes to zero. Its influence smoothly disappears.
So the extra UCTE term fades out.
Right. And the profound significance is this. It ensures convergence to the classical Navier-Stokes limit while inheriting global regularity.
Wait, so as the UCTE modification vanishes,
Yeah.
the system becomes the standard Navier-Stokes.
Exactly.
But because the smoothness was proven uniformly in epsilon,
it inherits that smoothness. UCTE doesn't just solve its modified equations. It shows that its well-behaved, smooth, augmented system smoothly becomes the classical system in the limit. And because the smoothness property holds uniformly, it carries over.
so it's a pathway to proving the original problem is smooth too.
That's the claim. It suggests that by properly accounting for coherence, even via this vanishing term, you can demonstrate the inherent global regularity of the classical system. It's an elegant, rigorous argument. So the math seems to track, showing how the system stays smooth. But you mentioned UCTE claims to be a theory of everything. How on earth does it connect this fluid dynamics proof to the fabric of reality itself?
Yeah, this is where UCTE goes from solving a tough math problem to something almost cosmic. It proposes this ontological superstructure, a four-floor skyscraper of understanding, grounding turbulence, not just in physics equations, but in the very nature of existence, connecting pure math to reality, even space-time. That's incredibly ambitious.
It is ambitious, absolutely. But the framework is designed to show coherence isn't just a useful mathematical tool for Navier-Stokes. It's proposed as a fundamental principle governing reality at multiple levels. UCTE argues turbulence, and maybe much more, fits into this four-floor structure, all centered on coherence.
Okay, let's take the elevator. Floor 0, ontological mathematics.
Floor 0, ontological mathematics, the meta-operator MathCal. The idea here is that NFNs arise as eigenmodes of MathCal, providing hidden invariance for turbulence stabilization.
A meta-operator. What's that, like an operator operating on operators?
Kind of. Think of it as operating on the principles of mathematics itself. MathCal isn't manipulating physical stuff directly, it's defining the fundamental mathematical rules of the game, the laws behind the laws that shape what can exist. And the NFNs are kappa, alpha, gamma, delta, emerge as its eigenmodes.
Eigenmodes meaning the natural, stable patterns allowed by this meta-operator.
Exactly, like the specific frequencies a guitar string naturally vibrates at, or the allowed energy levels in an atom. UCTE suggests NFNs aren't just arbitrary parameters, they are fundamental structures inherent to this deep ontological reality. They act as hidden invariants, quantities that preserve structure within turbulence, guiding it towards stability.
So the NFNs aren't just plugged in, they emerge from a foundational mathematical reality. Okay, that's deep. How does that connect to our universe? Floor 1.
Floor 1. Dimensional coherence, the 3+1 resonance lock point. This floor argues that 3D flows uniquely stabilize because continuous fields and discrete NFN attractors converge here. This is a key aha moment trying to explain our universe's specific structure.
3+1, 3 space dimensions, 1 time dimension.
UCTE posits that the stability of our kind of universe with its continuous fields like gravity and fluid flows isn't an accident. It's a consequence of these NFN principles operating. The idea is that continuous fields, like flows, can stably coexist with discrete NFN attractors. These quantized coherent states defined by the NFNs, specifically in a 3+1 dimensional setup. This 3+1 resonance lock point is the unique configuration, the optimal dimensionality, where these seemingly different concepts, continuous reality and discrete coherence principles achieve a stable harmony. It's the dimensional sweet spot.
The Goldilocks zone for dimensions, based on coherence. That's well thought. Okay, floor 2, emergent physics.
Floor 2, emergent physics classical laws as projections. This is where UCTE really goes for the theory of everything title. It states Navier-Stokes, QFT, GR classical laws are projections from deeper coherence fields.
So our fundamental laws, fluid dynamics, quantum field theory, general relativity, they aren't the bottom floor.
According to UCTE, no. They are emergent phenomena, like projections or shadows cast by underlying deeper coherence fields. Similar to how thermodynamics emerges from the statistics of atoms, UCTE suggests all fundamental laws emerge from a more primary coherent reality, a unifying bedrock.
Unifying Navier-Stokes with quantum mechanics and gravity through coherence. Wow. And the top floor. Floor 3.
Floor 3. Applied measurement direct falsifiability. This connects the grand theory back to Earth, back to reality. DNS, experiments, simulations, provides direct falsifiability via predicted turbulence thresholds and energy scaling anomalies. This is crucial. No matter how elegant the math or profound the philosophy, a scientific theory needs to be testable.
Right, you need predictions you can check.
Exactly. This floor is where the abstract framework meets the real world, providing concrete, testable predictions that can be checked with computer simulations, lab experiments, real-world observations. It keeps UCTE grounded in science.
It's fascinating how it builds from pure math structure up to testable physics. It's not just patching Navier-Stokes, it feels like proposing a whole new blueprint for reality.
Yeah.
With coherence as the foundation. And that claim about 3+1 space-time emerging, that's just astounding. How exactly does our universe's dimensionality supposedly result from NFNs and this resonance? 4.2 key result, the emergence of 3+1 space-time?
It's definitely one of the most provocative claims, stemming directly from that dimensional coherence floor. The theory states, the 3+1 dimensionality of spacetime emerges naturally as the NFN resonance optimum, where continuous flows and discrete quantization coexist stably.
The resonance optimum, the sweet spot again.
Exactly. Think about it. Why 3 space dimensions and 1 time dimension? UCTE suggests it's not arbitrary, not a cosmic fluke, but a consequence of these deep coherence principles.
How does coherence prefer 3+1 dimensions?
It's proposed as the optimal configuration, the resonance optimum, where continuous phenomena like gravity, electromagnetism, fluid flows, and discrete quantized phenomena like quantum particles and their interactions can most stably coexist and interact. In 3+1 dimensions, the NFNs supposedly ensure energy transfer and coherence are maximized, while instability and divergence are minimized.
What about other dimensions?
Well, consider 2+1 dimensions. We know vortex stretching is different, limiting the complexity we see in 3D turbulence. Maybe complex structures can't easily form? Now imagine 4+1 dimensions. Perhaps the interplay between continuous and discrete becomes unstable there. Maybe structures decay too rapidly or causality breaks down. The 3+1 setup, according to UCTE, is the just right Goldilocks dimension for a universe like ours, one that can form, persist, and support complex structures, including life. It suggests our universe's very dimensions are a direct result of these underlying coherence principles, a blueprint for cosmic stability baked into the math.
So our reality isn't just random math. It might be fundamentally tuned for coherence. Which brings us back to testing this. If this theory reaches from fluids to the cosmos, it must make specific falsifiable predictions. What should scientists actually be looking for?
Right. This is where the rubber meets the road. UCTE offers 5 specific cross-domain testable predictions. They span hugely different fields, which is part of the boldness. These aren't vague ideas. They are precise signatures scientists can hunt for. Find them, strong support for UCTE. Don't find them, the theory needs rethinking. 5.2 detailed breakdown of each prediction. Okay, first prediction. Quantized turbulence plateaus, the observable signature. DNS reveals staircase transitions in entropy growth.
DNS being direct numerical simulations, those super detailed computer models of fluid flow.
Exactly. And entropy is that measure of rotational energy. Instead of seeing entropy grow smoothly as energy cascades down in turbulence, UCTE predicts we'll see distinct step-like plateaus, like climbing stairs, not a ramp.
So turbulence energy doesn't just flow continuously, it jumps between discrete levels.
That's the prediction. This quantized behavior would be a direct sign of the NFNs regulating things, suggesting turbulence operates in distinct, coherent energy states, not just a continuous chaotic spectrum. It would be a dramatic find.
Clear, unambiguous, and very different from current models. Okay, prediction 2.
Prediction 2. Golden ratio coherence windows. Observable signature. Long-lived vortex tubes cluster at LI, golden ratio. Test method. Lab turbulence experiments.
Vortex tubes, like mini tornadoes or bathtub drains. And they cluster according to the golden ratio. L-approx 1.618 LOR.
That's the idea. These coherent structures, which can be surprisingly stable even in chaos, UCTE predicts they won't just form randomly. They'll arrange themselves, or their properties will cluster, around patterns related to the golden ratio.
Why the golden ratio? It pops up in nature sometimes.
Often linked to optimal packing, energy distribution, stability, think sunflower seeds, shells. Finding a governing structures in turbulence would be remarkable. It would suggest a fundamental design principle linked to the NFNs, connecting abstract math to fluid behavior.
Okay, staircase energy levels, golden ratio of vortices. What's prediction 3?
Prediction 3, energy spectrum shifts. Observable signature. Deviations from Kolmogorov's 53 slope. Delta Zeta proxies on a test method. High-resolution turbulence spectra.
Okay, Kolmogorov's F53 law. That's a cornerstone of turbulence theory, right? How energy spreads across different eddy sizes.
Exactly. It's a fundamental scaling law, widely verified, though maybe not perfectly. UCTE predicts a specific, small, but measurable deviation from this law. A shift in the scaling exponent by about minus 0.05.
That sounds subtle, but challenging a pillar like Kolmogorov's law, even slightly.
It would be huge. It's a direct, precise test of UCTE's reframing of the energy cascade as coherence-regulated. A persistent deviation like that would force a major rethink.
Wow. Okay, prediction 4 sounds even wilder. Quantum mass ratios.
This one really shows the theory of everything ambition. Observable signature. NFN eigenvalues predict standard model mass ratios. Test method. Lattice QCD simulations and precision particle data.
Wait. NFNs, the numbers from the fluid dynamics solution, predict the mass ratios of fundamental particles, like electrons and quarks.
That's the audacious claim. The eigenvalues are specific numerical values that naturally emerge from the NFN mathematical framework. UCTE predicts these numbers should correlate directly with the observed, highly precise mass ratios of particles in the standard model.
If that turned out to be true, that would bridge fluids and particle physics in a way nobody imagined.
It would be absolutely astonishing, a direct, powerful test of UCTE's unifying claims. And finally, prediction 5, space-time coherence bands.
Coherence patterns in space-time itself, how would we see that?
Observable signature. Discrete coherence signatures in CMB and LSS. Test method, data from cosmic surveys like Planck, DSI, Euclid.
CMB is the cosmic microwave background, the Big Bang's afterglow. LSS is the large-scale structure, how galaxies are distributed.
Correct. UCTE predicts we should find subtle bands or patterns of coherence in these datasets. Maybe
Looking for the universe's coherence fingerprint in the Big Bang's echo and the web of galaxies.
exactly. So these 5 predictions are specific, they are testable across scales from the lab to the cosmos, and they are falsifiable. They tell scientists precisely what to look for. If found, they could revolutionize physics.
And if it is true, if UCTE holds up, the impact would be immense. It connects fluids, particles, the cosmos. What are the practical and theoretical applications of a theory this grand? Where could it lead us?
The implications, if UCTE is validated, are truly staggering. They touch nearly every scientific and technological field, and even how we think about intelligence.
Resolving a Millennium Prize problem.
First, obviously in mathematics, it offers a potential path to resolving a clay Millennium Prize problem.
Which is huge in itself. Not just the prize money, but closing a major open question.
Absolutely. It's about foundational understanding. It would bring clarity to one of the most complex sets of equations we have, impacting areas like numerical analysis, PDEs. It would solidify our mathematical grasp on a key part of physical reality.
Unifying the ununified.
Then in physics, the ambition is immense. Links turbulence, quantum fields, and cosmology under a unified coherence framework.
The holy grail of a theory of everything.
A significant step towards it, potentially. Imagine bridging the chaotic world of weather with the quantum realm and linking both to gravity and the universe's structure. It suggests the principles forming a vortex might be related to forces shaping galaxies or determining particle properties. A single, coherent foundation for all physical laws. That's profound synthesis. 6.3 AI and intelligence. Intelligence as coherence restoration.
And then there's this fascinating angle on AI and intelligence. UCTE proposes NFNs define a symbolic architecture where intelligence, coherence, restoration. Intelligence is coherence restoration. That's a radical reframe. How would that work? Say, for something complex like climate modeling. How would an NFN-guided AI differ from current deep learning? Could it predict extreme weather better? Or even suggest interventions?
That's a brilliant question, hitting a high-impact area. Current AI, especially deep learning, is fantastic at finding patterns in data. But with turbulent systems like climate, it can struggle with long-term stability or capturing the underlying physics beyond just correlations. It might predict runaway scenarios that aren't physically realistic.
Right, it learns the data, not necessarily the deep rules.
Exactly. An NFN-guided AI would operate differently. Its goal wouldn't just be prediction accuracy, but identifying, maintaining, and restoring coherence within the system, based on understanding the underlying NFNs governing atmospheric and oceanic flows.
So it tries to understand the why in terms of coherence.
Precisely. For climate modeling, this could mean, first, more stable predictions. It might inherently avoid predicting infinite blowups for storms, seeing them as coherence-driven phase transitions, leading to more physically grounded long-term models.
Okay, better stability.
Second, identifying tipping points. By monitoring the NFN coherence parameters in the climate system, it could potentially spot early warnings of a loss of coherence, precursors to extreme events or ecosystem collapse much earlier than classical models might.
An early warning system based on coherence levels.
Yes. And third, the most revolutionary part, suggesting coherence-restoring interventions. If intelligence is coherence restoration, this AI wouldn't just predict. It could suggest actions to restore coherence. Imagine it identifying targeted geoengineering strategies, not just brute force cooling, but actions to stabilize ocean currents, reestablish coherent weather patterns, maybe reduce storm intensity by nudging the system back towards a stable, coherent state.
Wow. Moving from prediction to active intelligent system management based on coherence principles, that could apply way beyond climate too.
Absolutely. Social systems, economics, ecosystems, anywhere, complex dynamics involve coherence and potential instability. It's a fundamental shift from pattern matching to understanding and managing system stability.
Revolutionizing design and control.
That's incredible. And what about more traditional engineering? UCTE predicts breakthroughs in drag reduction, turbulence control, and energy transfer. What does that mean in practice?
Very concrete benefits here.
Drag reduction.
Understanding and controlling turbulence via coherence could mean much more fuel-efficient planes, ships, cars. Even a small percentage reduction on a supertanker or jet saves enormous fuel and emissions. Things could move faster, more efficiently.
Quieter planes, maybe. More efficient transport.
Potentially. Turbulence control. Think safer spacecraft re-entry by managing the intense turbulent heating. More stable flights in bad weather, more efficient industrial processes, better mixing in chemical reactors, better combustion in engines, reducing pollution, increasing power.
Better chemical plants, cleaner engines.
Yes. Energy transfer. We could potentially design much more efficient wind turbines that handle turbulent wind better tidal power generators, revolutionize cooling systems for everything from electronics to power plants, saving energy, boosting performance.
Decoding spacetime's blueprint.
And finally, back to the cosmos. In cosmology, UCTE offers testable predictions for phase coherence patterns in spacetime structure. If we understand these patterns, how does that change our view of the universe?
It could be transformative. Maybe new insights into dark matter and dark energy. Perhaps they aren't new particles or forces, but manifestations of these underlying coherence fields of spacetime itself.
Explaining mysteries without needing exotic new stuff.
Possibly. It might shed light on the universe's fundamental symmetries. Why are they what they are? Are they dictated by coherence principles? It could even inform theories about weirder things. Maybe new forms of space-time coherence could hint at possibilities for advanced propulsion or energy if we could learn to interact with them. Imagine detecting that subtle, coherent pattern in the CMB or galaxy distribution, actually seeing the universe's underlying blueprint.
It really is breathtaking. The sheer scope of impact, from abstract math to everyday tech to intelligence to the cosmos itself, UCTE feels less like just a theory and more like a potential unifying lens on reality where order and self-organization are fundamental.
Indeed. The unified coherence theory proposes a truly revolutionary perspective. It asks us to look at reality through this lens of coherence, right down to its foundations. 7.1 recap of UCTE's core achievement. So, at its heart, UCTE tackles the Navier-Stokes regularity problem by doing something conceptually new, embedding coherence dynamics directly into the Navier-Stokes system.
Not just a mathematical fix, but a conceptual shift.
Right. It reframes turbulence. It's not an instability-prone phenomenon doomed to chaos and singularities. It's a coherence-regulated cascade. The system, through its intrinsic NFNs and the dynamic stress tensor, is always actively working to maintain order, restore balance, even when things look wild. It prevents blowups by orchestrating this dynamic equilibrium. It fundamentally shifts the view from inevitable chaos to regulated self-organizing order. 7.2, the model's rigor and broad applicability. And importantly, this isn't just hand-waving. The model is presented as mathematically rigorous, physically grounded, ontologically generative, and experimentally testable.
It ticks all the boxes for a serious scientific theory.
It aims to. The mathematical proof strategy, with the admissible tensor, uniform bounds, vanishing limit that provides the rigor, the reframing of turbulence and singularities, the emergence of 3+1 spacetime that provides the ontological depth. And those 5 cross-domain predictions offer concrete falsifiable tests. Its power lies in this grand synthesis, attempting to bridge fluid mechanics, quantum theory, cosmology, and intelligence systems under one single coherent framework. It suggests an elegant, unified design woven into the fabric of the universe. #outro.
This deep dive into the unified coherence theory, well, it's really shown us a universe where a profound order might underlie what we thought was pure chaos. It makes you wonder, what if coherence isn't just a property of things, but maybe the fundamental operating system of reality itself, actively maintaining stability, enabling complexity? If we could truly grasp and maybe even engineer with these Noetherian-Finsler numbers, what kind of coherent future could we build? From smarter AI that understands stability to finally unlocking cosmic secrets hidden in space-time structure. It paints a picture of a universe that feels more interconnected, maybe even more intelligent, full of hidden order waiting to be understood.
It definitely challenges us, doesn't it? To look past the apparent randomness and search for those hidden structures, those eigenmodes shaping everything around us, from coffee swirls to cosmic webs. And it raises that big question. What other coherence principles might be operating in systems we currently label as unpredictable or chaotic? And how could understanding them unlock entirely new frontiers in science and technology? It really encourages us to keep digging for that underlying order, maybe with a renewed sense of purpose, guided by this idea of fundamental coherence.
We certainly hope this deep dive has given you a shortcut to getting your head around this complex and potentially revolutionary theory, and maybe sparked your own curiosity about just how deeply interconnected our universe might be. Keep exploring, keep questioning, and keep diving deep.